Now let's think a little bit about what happens at this last step, where we're actually computing the error estimates for each of the methods and picking the best. I've taken the time off camera to put together a little toy example of how that will work. So we're thinking here about making 3 forecasts. We're going to call them now plus 1, now plus 2, and now plus 3. So we're going 3 periods into the future. Whether those are 3 days, 3 weeks, 3 quarters, or 3 years, doesn't matter. It will be whatever your planning process requires. But here we have 3 forecasts. And here we have the actual values for this item. The next period beyond the history that we're using to compute the forecast would be a 50, and then the next one a 55, and the next one a 60. So you're seeing some sort of, it looks like there's a trend here, a positive trend. Now these numbers would come from the holdout data. We've hidden those from the calculations because we want to see if we can correctly predict what actually happened without cheating, without looking at it ahead of time. So here is the truth from the holdout data, and then a particular method would make forecasts, and this particular method forecasted a 48, and then a 51, and then a 63. So it was forecasting some sort of increasing demand. But how do we assess 48, 51, and 63 compared to the truth, which was 50, 55, and 60? Well, here's the error, which is the actual minus the forecast, or I'm sorry, the forecast, the actual minus the forecast. So the error in this case was plus 2. The actual was 2 above. In the second period into the future, the error was plus 4. In other words, if we took the forecast and added in the error, we would get the truth. So we take the forecast, and if we'd have just gone up 4, we would have hit it exactly. And in the third period, we actually overshot. We had a 63. If we had come 3 lower, we would have hit the truth of 60. So we have now 3 error figures, plus 2, plus 4, and minus 3. And what we need is a single number to describe, on average, what happens in this planning problem. We've got a 3-period forecast horizon. What's the average over 3? And we take the absolute error, which means we ignore the minus signs. So plus 2 stays as plus 2, plus 4 stays as plus 4, minus 3 becomes a plus 3. We don't let this subtract and make the total error seem smaller than it is. And so a 2, a 4, and a 3 average out to a 3-unit error for that method over the 3-period forecast horizon. And that would be the error estimate which we would compute for each of the competing methods on this item. And of course, for the next item, we'd go through the same calculations. But when we look at these average errors, we obviously pick the one that is the lowest, and we say there's a match now. A particular method would, the winner of this tournament is the one we will assign to making the forecast for that item. And the next time we do this, maybe 6 months from now, we have a repeated planning exercise, we will recompute things. It's all zero-based. We don't say, well, this one worked well last time, so maybe we're just going to persist and use that technique on item 7. No, because the world may have changed, the demand pattern may have changed, and now the method that worked well 6 months ago is not the best thing to do now. And so this process just recomputes everything from the beginning, and in that way it adjusts to the changing business environment that you're dealing with.